Hi, I'm Fabio and welcome to the 5th course about the Python Introductory course series by Matplotlib.com. In today's course, we will see how to produce static plots using the Matplotlib and Seaborn libraries. So let's go back to the Python projects folder, and I already create, as you can see here, a new folder named COVID Pandas Plots. In particular, in the COVID Pandas Plots, you can see a folder named Data, in which I've stored all the data in a CSV format that we will use during this course. In the docs folder, I stored some documentation that we will see in a minute. In the image folder, I've saved only the picture about the Italian regions. That in this way we can plot this picture in our Jupyter notebook. And finally, forgetting about the other folders, we have the requirements txt file and our notebook that in which we will work on. In particular, I've already created the virtual environment for this project, and I already installed the Matplotlib and the Seaborn libraries. I just typed pip install Matplotlib and pip install Seaborn. Nothing special. Also, you can see that I have already activated the virtual environment in the COVID Pandas plot folder. Next thing we will do is just to type Jupyter Lab and activate the Jupyter Notebook environment. But before this, I want to introduce you in the world about the static plotting using Matplotlib mainly. So let me show you what I have here in the browser. And let me move here in the PyPlot tutorial. So Matplotlib is a gigantic library, Python library, but usually you will use just a module inside the Matplotlib called PyPlot. Why this? Because as you can see here in this tutorial, the PyPlot tutorial on my Matplotlib, this version, but this tutorial is quite old, to be honest. PyPlot is a collection of functions that make Matplotlib, this gigantic library, work like MATLAB. So the idea is to use Python to produce plots that are quite similar to the ones that you can produce using another programming language called MATLAB. Also, each PyPlot function makes some change to a figure. For example, it creates the figure, creates a plotting area inside the figure, or can do other things like plot some lines, decorates the plot with labels, and so on. One important thing is that in Matplotlib PyPlot, the various states are preserved across function calls. In this way, you can create a figure and you don't necessarily need to refer always to that figure to, for example, add some labels to the axis. Because the states, for example, the figure state, is preserved across all the function calls that we will make after the creation of the figure. So in this way, as the documentation says, this keeps track of things like the current figure, the plotting area, and the plotting functions are directly to the current axis. We will see in a minute what we mean with axis. In fact, as you can see here, we import. The convention is to name a pyplot to abbreviate Python with plt. So we import matplotlib.pyplot, the submodule of matplotlib, as named plt. And in a simple way, we can write plt.plot 1, 2, 3, 4. These are the y values, and if x is not provided, it will be 0, 1, 2, and 3. So plot, what does plot do? Well, it creates a figure and an axis, and we will see in a minute what it is, and also plots a line, as you can see here. That's the result. But in the third line, we say plt.ylabel some numbers. And we are not actually referring to the figure we have created in the second line with the plot, calling the plot function. But still, the ylabel is changed. Also, in every plot, for each plot we will do, we will say plt.show. In this way, for example, in our Jupyter Notebook document, pyplot will understand to present us the plot, the figure we have created. For example, if I want to save, to store the picture, the figure, I will not use plt.show, but I will use plt.save, if I remember correctly. So we have understood that pyplot is a powerful library, and during each call we do not have always to refer to the figure we are trying to modify. But how is built the figure? Let's take a look to another tutorial in Matplotlib, and this tutorial is called Usage Guide. In here we will see a simple example. Let's see what the documentation says. So Matplotlib graphs your data on figures. So as you can see in orange here, figure is a class inside Matplotlib, in particular inside pyplot. And each figure can contain one or more axes. Okay, what are the axes? For example, axes are an area where points can be specified in terms of xy coordinates. Interesting. So the simple way, and the most simple way of creating a figure with an axis is using pyplot subplots. And then we can call axis.plot. So pyplot gives us two ways to create a figure. One without referring specifically to axes, and we will see in the Jupyter Notebook when talking about the COVID data how we can do that. And the second way is to create the figure and also explicitly create the axis. In this way, instead of referring to the figure itself and attach some properties to the figure, we can refer to a specific axis. As you can see here, in order, as the documentation also says, the most simple way of creating a figure is to use plt.subplots, which returns the figure itself and all the axes specified in the properties in the arguments of the subplots function. That here, since there are no arguments, this is only a one axis. But the most interesting thing is this: parts of a figure. Okay, so how is described a figure? Let me zoom out a little bit so we can take a look at the whole picture here. Okay. So a figure, here we don't look specifically at an axis, but we have that a figure is described by a title, okay. Then we have a sort of grid here, which is the grid, and is created by the, it can be confusing, these axes, which are not the axes that were referring here, axes with the A, with the uppercase A. But in the usual terminology, the x-axis and the y-axis, which have both an axis label, okay, an x label and a y label. This is the figure, and we can see there's a legend. We have major tick labels, minor tick labels, ticks with their labels, and so on. Inside the figure we have a line plot, a scatter plot, and several other things. As you can see here, the whole picture is called in Matplotlib a figure. But you maybe in one picture you want to plot several, let's say, lines or scatter plots that do not have in common the x and y axis. In this way you can create multiple axes that split the figure in different parts. So this is it. I can understand that the difference between figure and axis can be still a little bit confusing, but because here we have only one graph. If we will use instead in our COVID analysis several graphs inside one figure, and each graph will refer to one of the axes. So let's go back to our terminal, and finally, since the virtual environment is already active, we type just Jupyter Lab. Let's wait a minute. Here we go. And here we have finally our Jupyter Lab. And the notebook I've already created here. This is called the COVID analysis plots. First thing we can see here, okay, we have the title, which is the same of the previous notebook from the previous course, analysis of the misalignment between non-COVID reported deaths and those estimated from the past. So remember that we are studying in a data science way the reported COVID deaths, and in particular if during the 2020 the COVID reported deaths were sufficiently accurate, because from the past, from the previous year, I can estimate the average deaths per month, for example, and I can compare the past results, this mean, with the non-COVID reported deaths in 2020. If there's a significant difference between these two values, well, maybe some non-COVID reported deaths were actually COVID deaths. But so let's begin with our analysis. As you can see here, we import the matplotlib.pyplot module, and we abbreviate this by PLT. We import pandas because we will deal with data frames and the tables, and also we import another library, Seaborn, that is also abbreviated as SNS. Seaborn is an advanced library with respect to pyplot. In particular, it uses pyplot to print, I would say, plots in a more simple way. In particular, Seaborn is very handful combined with pandas data frames, because you can specify the data frame and the columns as strings. And with a few lines of code, you can create very beautiful plots. In my pyplot, instead, you have to do several adjustments to colors, to labels, and other properties in order to get a pretty graph. Also, I import Matplotlib and a specific class here called path. In the previous course, we used OS to deal with the paths in our system, in our operating system. Here we will use instead the matplotlib.path class, which I think is a modern way to deal with files and paths. In particular, here, let me go back, let me show you the folder. The data is stored inside the data folder, and in particular in the COVID analysis. In the COVID analysis directory, in fact, I stored all the results that we extrapolated in the previous course about the COVID and non-COVID deaths. So, for example, here we have the cumulative COVID daily deaths. Here we have the historical COVID monthly deaths comparison. So we are comparing the COVID deaths with the past deaths from the previous years using a monthly time frame. Then we have the historical monthly deaths that we will not use, and then we have the incremental COVID daily deaths. Okay, let's go back to our notebook. Let's run the first cell of our notebook, and in order to import the libraries. As you can see here, I've already created two paths, the analysis path and the istat path. In the analysis path, we refer to the data COVID analysis path. Also, I didn't show you 1 minute before that I also imported in the data istat folder a new CSV file, and we will see why in a minute. So let's run this. I simply type this path If you note, I'm using the Linux notation here for the path, and as a string, and this will be the argument of our path class. So what actually is now analysis path? Well, automatically path recognizes that we are on a Windows operating system, so path will become Windows path. But still we have the notation used in Linux. But when I take the string of analysis path, you can see that the path class automatically adjusts the path referring to the operating system on which I'm working. And that's why you can see this double backslashes here. Let's remember how are defined the Italian regions. We have 20 Italian regions, and in particular we will focus on the Lombardy region here, where there's Milan. We will focus on Veneto, because it's basically near Lombardy, so we can measure the difference of effects between the Lombardy and one region near the Lombardy itself. Then we have, for example, the Lazio, where we can find Rome. Also we have Emilia-Romagna and the Tuscany. Finally we have the Sicily. We will focus on these regions. Moving on, let's start as in the previous course with the cumulative COVID deaths. Here I import the CSV called cumulative COVID daily deaths, which is inside the analysis path. The cool thing about the Matplotlib is that I can use this notation to append this path to another path. I'm not dividing, but the notation here is very similar to the Linux notation for defining the hierarchy, folder hierarchy. So that's why Matplotlib implemented this shortcut for the joining different paths. Then I take the string of this, so the path is converted into a Windows format, and then I use this another option, Parse Dates. In particular, here I specify in a list the 0th element. That's because I already know that in this CSV the first column is a date. So thanks to this option Parse Dates, automatically the pandas read the CSV will convert the 0th column to a pandas date time type. Let's run this cell, and also we can take a look on what now is this COVID. Here we have cumulative COVID daily deaths, and we take the info. So the 0th column is a date as expected, and thanks to this Parse Dates option, it's already converted as a date time data type. Then we have region and deaths. Okay. Now let's look at some elements. Let's take an head first. So we have the date, Abruzzo, which is one of the regions. For example, here is Emilia-Romagna, and we have 0 deaths. Okay, but because we are in February, where the first cases of COVID were reported in Italy. Let's take a look at the detail, since I already know that the dates are sorted. So let's take a look at detail, and in particular the last 10 rows of this table. Okay, we have the table. The maximum date is the 17th of December 2020. Okay, so let's focus on, let's create our first graph, and in particular, for simplicity, we will focus only on one region for now, which is Lombardia. Let me... Okay, so this doesn't make too much noise for... So here what I do, I take the table and I query it, but saying region must be equal to Lombardia, which is in Italian which can be translated in English as Lombardy. And I store this subset table in a TMP variable. Now create our first plot using Pyplot. I prefer to always declare the figure, so in order to do so, I type plt.figure. And also I want to specify the dimension of the figure using the fig size, option, which will take a tuple, and the dimensions are described in inches. For example, here I want 10 inches as width and 8 as height. Okay. Now I want to plot. So I want to draw a simple line. So as we have already seen in the tutorial, I'll type plot. And what can I do? I take tmp dot as x-axis. I want to use the date, and as y-axis I want to use the deaths. So I want to plot the deaths against the time. Finally, in order to take a look at the output, let's type show plt.show. Let's wait a minute, and here we go. We have our plot. As you can see here, the data frame was described using on a daily basis, but since the date is a datetime object, Matplotlib automatically understands that this is a date, and it groups the points in such a way that the x-axis is not that dense as taking all the days. But this graph is pretty naked. The x-axis is fine. We understand that these are dates, in particular months of the 2020. But what are these values? On what does this line refer? We need to add some something to this plot. Also note a thing that I don't like a lot, and this is 0 deaths is not at the bottom here, but there's a gap between the x axis and the actual 0 in the y-axis. So let's first fix this thing just by saying plt dot y lim, which is the limit, wide limit, and the bottom limit is equal to 0. Let's rerun and we will see that, okay, that's nice. Now let's add a label to the y-axis. In order to do so, I just say plt.ylabel. Remember what we have seen in the tutorial. Pyplot refers here, creates a figure, and all the other calls just refer to the figure itself. So here we have the label and we see total, and we say total deaths. Let's rerun total deaths here. Okay, it's a little bit small, this text. Let's make it bigger, and by specifying this size option 12. Oh, okay, that's a little bigger. Now finally let's add a title. We type here plt.title and we just specify the text. So Lombardy, for example, cumulative COVID-19 deaths during 2020. Seems fair. Okay, still a little bit small here, so let's say maybe 16. Okay, so this is the Lombardy cumulative COVID-19 deaths during 2020, and we can see here the dates, okay, the timeline, and the total deaths that of course increase over time. Here you can already see two things. Of course, we are taking a look at the Lombardy, one of the, if not, we will see later, which is the region that reported the highest number of COVID-19 deaths, unfortunately. We can see that between when the curve here goes almost vertical, it means that there's an acceleration of deaths during the period. If the line instead is almost flat, it means that during time not a lot of deaths were reported. And here in fact we can see the two waves, the first two waves of COVID-19. The first wave, where the virus were first discovered, and the second wave, the autumn/winter wave. Because here the cases, the number of deaths increased tremendously. Then they almost stopped, the people almost stopped dying, and then around October, November 2020, that's started again to increase. Okay, this is our first plot. Let's maybe recap a little bit. So we have created here a figure. We have attached to a title to the figure just by providing the text and the size. Then the core of the plot of our figure is the plot itself, and we have provided x values against the y values. Then we have specified the y limit, in particular the bottom y limit, the y label, and then we have told to Matplotlib, show me the figure. Once we show the figure, we cannot modify again that figure. That figure is gone. That's why it will always be the last command you will run. Okay, we have taken a look to one region only. Now let's look at multiple regions. For example, Lombardy, Veneto, Lazio, and Sicily. Let me go back here. So let's take a look to Lombardy, which will be our main focus. Then Veneto, since it is one of the region near Lombardy. Then we take a look at the Lazio, which is in the middle Italy, and then Sicily, which is in the bottom of the Italy and also is an island. Okay, so I defined here the regions. Now I want to create a figure in which there are multiple graphs, one for each region. How can I do that? Well, I can use the Subplots function as specified in the user guide tutorial. So, Matplot subplots return a figure and an axis. We will see in a minute what axes here are. And it takes as arguments the n rows and columns and fixed size. Fixed size, why? Why there's an option, the fixed size option inside subplots? Well, because subplots, as I've reported here, the documentation creates a figure, that's why it returns a figure, and also a set of subplots, the axes. How do I want to arrange these subplots? Imagine a grid, and you can choose the number of rows of that grid or the number of columns. Here I want 4 rows and 1 column. This function can be confusing because there's another function, subplot, which only adds a subplot to the current figure, and if no figure is defined, it creates itself, but you cannot specify properties about that figure, since subplot implicitly defines it. So in order, for example, to define the fixed size of the figure, you have to explicitly create the figure and then to add an axis, a subplot, to the figure. Okay, here we will run subplots. Let's forget about this. What is axis? It will be a list of axes, and this axis list will have 4 elements, corresponding, of course, to the 4 rows we have specified here. Also, I can add a superior title. Since there will be a lot different subplots, I can define a title for each subplot and also a superior title for the entire figure. Here, in fact, we will define the superior title as the cumulative COVID-19 deaths during 2020. Now we have to create the each subplot. In order to do so, we will use a for loop. So we will use for e region, and you will see in a minute why I use also the position, enumerate regions, the position of the region. We create, now we want to extract from the entire table, the cumulative COVID daily deaths table. We have to extract the information about only the specific region. So we create a mask, and this mask will be cumulative COVID, let's see if it works, region should be equal to region. Okay. Then we access to axis, in particular to the E element. That's why we have here. Because for each region we will refer to a different subplot. We first set the title, because how can we know that that subplot refers to that region? We create a title for that specific subplot. So we type set title, and the title will be actually region, the region, and I already know that the size will be small, so I make it bigger, specifying size equal to 14. Then I finally draw the line. So I will do so by using the plot function. And the plot function is quite interesting if you are using a data frame, because you can specify an option data, and which will be cumulative COVID daily deaths with the mask. And also you can specify the X and Y labels just by referring to the name of the column and reporting them as strings. So the X column will, the X variable will be date, and the Y column will be deaths. Note that unfortunately with pyplot, if you type here AX, X equal and Y equal, you will get an error. Type in this, you will get an error, so you must not specify these values as key arguments, but just as arguments. Okay. Let's then, as we've seen previously, we have to also define a label, a Y label. So here we, with the when applying a function, when calling a method of the axis class, the method is named a little bit differently than when calling the same method basically from the pyplot library directly. So if I want here to change the Y label, I call plt.ylabel, and the pyplot will automatically understand that I'm referring to the figure I create here. But if I want to change the label only of this specific axis, I have to call the method inside the class, and this is set Y label. Set Y label, and it will be total deaths. Oh my god, what happened? That's okay. Finally, the size will be 12. Okay. I also want to specify the set y lim bottom equals to 0. Generally speaking, when referring to the axis, you have to use the method with set underscore and then what you would use using only pyplot. Then we type plt.show and we will see that a mess will happen. So, cumulative COVID-19 deaths, okay, but the title here, as you can see, we have 4 rows, 1, 2, 3, and 4 subplots, 1 for each row, but the titles are quite messy. So how can we fix this very fast? We can just call the type layout that we will fix our problems and will automatically understand that the subplots should be separated. Another thing that I want to do is also to change the colors of the lines to let understand that each line refers to a different region. So I can specify here inside the plot the color property. And automatically pyplot refers to a palette of several colors. And each color can be accessed, for example, as a string, for example, C0, C1, C2, and so on. So here, what I can do is just say this one. The color will be automatically changed. So here, I have that the color 0 is this light blue, then the orange, then the green, and then the red here. That's fine, but still those lines are too difficult to be seen. I would like to fill the gap, fill the area under the line, and I can do this in a simple way, just by referring to the axis, the proper axis, and calling the method fill between. I have to specify, here you can see, I have to specify the x, the y1, which will be the bottom, and the y2, which will be the upper limit of this region that will be filled with some colors. So here we can use the same notation as here. The color will be the same. Why I can do that? Because automatically, if I do not specify the y2, automatically the fill between function will understand that I want to fill between these values and the x-axis. Let's run, and you will see that things are a little bit confusing now, because we have filled the region with the same color of the line, so the line can be seen anymore. It's part of the region itself. So let's correct the opacity of the filled color by typing alpha, and we will type, for example, 0.6. Alright, so here the line is still visible, but also just by taking a quick look at the plot, we understand that these four lines refer to different regions, to something different. Okay. Now, on a data science point of view, we can see something else. The scale here is not shared. In fact, the Lombardy has a lot of cases. In December 2020, there are more than 20,000 deaths were reported from COVID-19. While for example, in Veneto we have 4,000, 5,000, and even less, for example, in Sicily. Another thing is that you can already see here that the first wave, when COVID-19 were discovered, seems somehow stronger in Lombardy and in Veneto with respect to, for example, Lazio and Sicily, where here 0 cases were reported in March, for example. All right. So the main thing is that in this graph, okay, we can take with a plot we can look at 4 regions differently, but the axes are not shared. We can share the axis by just adding here the proper option, but in doing so, let's see, share y, if I remember correctly. Let's see if this is correct. Is this correct? Yes. If we do so, yes, Lombardy remains the same, but all the other plots seems quite strange. So a better approach should be used here. For example, we can plot the different lines on the same axis, the same subplot. And that's what we will do here. So we will look at the same for regions. We create a subplot here with only 1 row and 1 column. We create only 1 subplot. If we specify, if we tell to the subplots function that we want to create just a subplot, it will not return as a list. Here will not be a list with only 1 element, but subplots will return the element itself. This is more convenient, since, for example, to plot we will not use x0. No, we can just refer to x. We will add the same superior title, and now we will do the same thing. Let's copy paste this. Changing something, because the mask, okay, this remains the same, the region remains the same. I'm looping through the regions, okay, that's fine. But here the x will be the same, and subtitle, no, that's not my thing. Plot, yes, I want to plot different lines in the same subplot, where I will use date as x-axis and that as y-axis, this data with using the mask I've previously defined, and the color, okay, the color remains the same. Also, I want to fill the gap between the x-axis and the line. I just type then axis, fill between, dates, the links remain the same. Why label? Okay, that's fine. I can tell you this, but also I don't need to loop through the regions. The subplot is one, so I can tell this. The same for the while limit. Also here, how can I understand that that specific line will refer to that region? Just by knowing the color, but how can I know the color? And that's where we want to create a sort of legend. We can specify the label that we will use in the legend just by typing label equal inside the plot method region. Also, since the legend will be quite small, I want to increase the size of the legend, and I can do so by accessing the legend and telling that one of the properties, the size property, should be equal to 12. Then I use the title layout and show, as always. And here it is. Maybe let's use an alpha a little smaller, like 0.4. Okay, that's nice. So here Lombardy is this this big blue area. Then we have the orange one, the Veneto. Then we have Lazio in green and Sicily in red. Quite cool now, right? Because now we can actually compare the total deaths. Okay, so there have been reported a lot of deaths in Lombardy. But what about the other regions? These are 4 regions on 20 regions. And this is where we can start to take a look at Seaborn, which comes a little bit more in handy to deal with this particular setting. Let's create, first of all, we want to do something like this. Let me present first what we are meant to do now. We want to create a graph like this without the colored area, just the lines, the colored lines. So we have to use 20 colors. So remember that the colors came from a palette. We have to create the palette. And Seaborn allow us to easily access to colors palettes by using this function, the color palette, and by typing the name of one of the palettes that you can find at this link here. So for example, here I ask Seaborn to create for me a palette of 20 colors named tab 20, and these are the 20 colors. Okay, so right now let's create the figure, add the superior title and so on. Then what we want to do? We don't want to loop through 20 regions and with pyplot add a line to the same axis all the time. Let's use a smarter approach and start using Seaborn actually. So In Seaborn we can create a line plot by typing SNS line plot. Simple like this. We have to specify the data that we want to use. So data will be our cumulative COVID daily deaths, without any mask, of course. Then we can specify X. What will be our X? The date column. And the Y, the deaths. But also we want to filter. We want to create 20 lines. So we can specify a sort of filter called U, and this will be described by another column, the region column. Region. Okay, let's run. There we go. That's quite nice, because we have different columns. It's quite difficult to take a look here. Why? Because we do not have access to the palette we have seen in the previous cell. Then also we want to make this legend a little bigger, especially in the line part, and that's another point. Then we have to fix the X and Y labels, because automatically the Seaborn line plot will add for us the date and deaths labels. But we do not want the date label, since it's obvious. Here we want to specify that this is total deaths, and finally 0 must be Y equal to 0 must be positioned here in the x-axis. Let's do one thing at a time. So specify the palette equal to the palette we have defined here and named palette. Let's take a look at the change. Excuse me, I have made a mistake, because your palette... oh, okay, because we do not have run. Okay. Okay, the colors are different, but still not perceivable. Let's increase the line width then. Line width, which can be abbreviated by LW, excuse me, and this notation is also used in Python Pyplot module. So line width of 5, and also let's add an alpha, just to make things prettier. Okay. Quite nice, but still we have to modify the labels here, the Y limit and the legend. We have already studied how to modify the Y limit and the labels. So Seaborn, when creating a plot, outputs the axis. So we can do axis equal and get the axis where that line plot was actually plotted. Okay, and then using this we type axis set Y limit. Axis. Now we want to delete the set the X label. The simplest way to do it is just to say label and an empty string. Okay, Let's run. Quite nice. It's quite nice. Okay. Let's adjust the legend. You can see here also this line plot created the legend, naming region, adding the title of the legend. Then let's create the legend by axis.legend, and as always we want to increase the font size from prop as a dictionary size, and we put this as 12. Also, there are a lot of regions, so why not break the legend and in 2 columns? So we can specify this by typing ncol equals to 2. Let's run. Cool. Okay, but the colors are the lines here in the legend are quite small. Also, since here we have redefined the legend properties, the name of the legend itself has been deleted. In fact, we already know just by taking a look at these names that these are regions, Italian regions. So we want this will be our legend object. We want to modify the legend, so we have to do line, we have to loop through what? For line in legend get lines. Give me the lines, and by lines we mean each of these row here as a one line and one text box here. So we are accessing each line, which will be, thanks to this legend get lines, an array of 20 lines. And accessing one line at a time, we say line dot set line width okay, to 12. Oh, that's bigger and very nice. So looking at the 12 at the 20 regions, we know that Lombardia here, the Lombardy, is the region that in which there are reported more deaths. Then we have this green and orange here. So we have Emilia-Romagna, and this line should be, let me find, should be Toscana, if I remember correctly. So these are the regions where more deaths were reported. For example, Veneto, let's say, is the 4th region. But each region has its own dimension and its own population. So if the region is quite bigger, is more likely to have reported a lot of deaths. So the correct approach, the data science approach, is not to look at the absolute numbers, but to look at deaths in proportion to the population of that region. For example, we can measure the deaths per 1,000 people, per million people, but how we know how much people are in those regions? And that's where another table comes in handy. So in the section here, people per Italian region, we will extract the population for each region. In the stat path, in fact, you will find a CSV file, population per region. Let's import this and let's take a look at what is inside. Region, year and value. So we have, looking at add, for each region and for each year between 2012 and 2020, let me show you this. 2012 to 2020, the population inside that region. Quite useful, because now we can divide these numbers by the population in 2020. So that's per million people. We will use this scale. We take the the cumulative COVID daily deaths, and we will merge this data with the table we have just imported, which is called Italian people. And in particular, what data we will capture here. So we use the lock. We will refer to the year 2020. And we will extract the region column and the value column. Okay. So we have the Italian population table referring to 2020 with region and value columns. All right. Now we can merge this table with the cumulative COVID daily deaths, on which key the region column. Also, this name value could create a little bit of noise and misunderstanding inside the table. So let's rename immediately this by typing rename columns, and as a dictionary here we rename value to just people. Let's rename as people. This will return a table, right, with date, region, deaths, and finally people. Now we will store this information by overwriting the cumulative COVID daily deaths. Okay. Now we have, let's take a look again at what we are talking about. We have the absolute number of deaths, cumulative, and the number of people for that region. Let's compute the ratio. So cumulative COVID daily deaths per million will be equal to the scale, the million, times the cumulative COVID daily deaths dot deaths divided by the cumulative COVID daily deaths people. So we have the ratio deaths over people, but for million. Let's create the column and run the COVID And let's take a look at to the COVID daily deaths table. Here we have our ratio. Let's plot now this ratio. And the idea now is to compare the total deaths against the deaths per million people and see if something changes. How can we do this? Well, we can do for each, we want to create here two subplots. In fact, we have columns equal to 2. So let's do a loop for each subplot, which will be k, and a loop for k in range 2. So we have 0 and 1. Then we loop for each region, because in each subplot we will print all the 4 regions. So for region in regions, of course this will be enumerated like this. We create the mask, which will be cumulative COVID daily deaths region equal to region. Okay. Let's print. Let's access the k subplot and plot what date, and the y column. Y column will be deaths for the first subplot and deaths per million in the second graph. So here let's write y column equals to deaths per million if k is greater than 0, which here will happen only one time when it is equal to 1. Otherwise, else the column will be deaths. Also, we already know that we will refer to different y labels, so why not define it right here in the same way? So y label will be deaths per million. Let me delete this. Deaths per million people, and here will be total deaths. So returning to the plot function, we want plot with the date as in x, so date against the y column. Finally, will be the data, will be cumulative COVID daily deaths with the mask. We will have color, it's always the same. This one will be C, I, okay. And then I will just copy paste from my notes here. So we will do things faster. We set the label as y label. We will fill between date and y column, of course, with this alpha. We'll use this set limit equal to 0, and also for each subplot we customize our legend to make it bigger and to move it on the upper left side. Let's I think we can run, but I also forgot this. We have to add the label here, which will be our region. Okay. Here is the result. Now that we have produced this this figure, let's take a look at the actual results. So on the left side we have the total deaths, and comparing the subplot on the right side, we have that of course the Lombardy curve will be the same, because the y-axis are calibrated with respect to this line. So these lines are actually the same. The only thing that's changed here is the scale. But we can see that if we refer to the absolute deaths, we are actually underestimating the effect, the COVID-19, the effect for the other regions, in particular for Veneto. In fact, looking at the deaths per million people, the gap between Lombardy and Veneto is smaller than when using the absolute total deaths. Quite interesting, right? So that's why maybe we can compare Lombardy against Veneto. And here I've already created the graph, just because I don't want to spend the whole courses about typing Matplotlib functions. But here you can see that I use Twinks, the Twinks function. I create a subplot with only one axis, and then I initiate a second axis that shares the same x-axis. Quite interesting, right? So in the same here graph, I use two axes. Here that's per million people, and here the total deaths in the same graph. And one line will refer to the deaths per million, the solid one. Here the solid one for Lombardy, and here the solid one for Veneto. The dotted one instead refers to the total deaths, where you can see that looking at the deaths per million people shortens the gap between the two curves. Okay, another thing that I want to point out is the fact that here I have created a custom legend, because it's quite difficult, if not impossible, to be honest, to handle legends using two axes on the same plot and so on. So here I have created my own legend. In order to create my own legend, I have to define the labels and the custom lines. Here I have the lines, and this is instead the labels. For e equals to 2, which are the columns, what I do? I add two labels, the total deaths or the deaths per million, which will be my title. And here I create a fake title, let's say, just by adding another label to the legend without specifying a line. In fact, here you can see that I add to custom lines a line 2D with line width equals to 0. This is. And then I add two custom lines, two lines, because the regions are 2, with width 4, these two. So I add first this one, and then these two, and then the others. Okay. I do the same for Emilia-Romagna and Tuscany, but let's move on. So, incremental daily COVID-19 deaths. Well, we have seen so far that the two waves that happened in 2020 in Italy, but it's quite difficult looking at the cumulative deaths, how the strength of that affects. In order to do so, we have to refer to the daily deaths. And this data is reported inside this table, incremental COVID daily deaths. So let's import this table and rename. We can find here. Let me show you the row table. We have date, region, and COVID deaths 2020. We will rename the COVID deaths 2020 as deaths for our convenience. So let's rename and let's rerun this cell, date, region, deaths, as the previous column. Here we have none because we have computed the difference. We can also do, for example, fill NA with the 0 and in place equals to true. Okay. In this way we will fix the things. For example, here. Okay. Let's take a look, for example, at what we mean by incremental. It means that if we take a look at tail 10 for Veneto, these deaths are not actually cumulative. We do not sum the deaths between days, but are the actual dates reported, the actual deaths for the reported day. Let's compare then the phenomenon using this data. And we will use, let me just copy paste, we will use just Lombardy, Veneto, Lazio and Sicily. We will create only one figure with only one subplot with superior title Daily COVID-19 Deaths During 2020. And in order to create this, what we have to do? We have to loop through the regions. We create the mask and we plot date against deaths. We set the Y label as daily deaths because now we are not talking anymore about the total deaths, but only the daily deaths. And we fill the area between as before. Let's print out. Okay. Wow. Now the two waves are very, very clear. You can see here that in Lombardy, the first wave of COVID was quite strong. Then the first wave involved March to June, July. Then in the summer, almost no deaths were reported. But when the autumn/winter came and the second wave happened, and again we see that the daily deaths, the absolute value of the daily deaths was quite high for the Lombardy and actually Veneto. Also, another thing that we can say is that for Lombardy, for example, the strength of the first wave was higher than the second one. But the opposite happened for Veneto, Lazio and Sicily. In fact, here you can see that for the orange line, which is Veneto. The peak for the first wave was lower than the peak for the second wave of COVID. Quite interesting that this effect could not be seen very clearly in this graph, for example. It's very difficult, for example, because the daily deaths here are represented as the slope of this curve that increases over time. And here the slope is quite difficult to compare, except for the first one, of course. But in this graph, the things are very extremely clear. But again, here we are comparing absolute values. The absolute value of the daily deaths for that region. In order to fairly make a comparison between the day deaths through regions, we have to refer again to deaths per million people. So here the steps that we have to do are the same. We merge our incremental COVID daily deaths table with the Italian population, Italian people table. So let's run. We select the scale as the million, and we create the deaths per million column. Okay. For example, here we have for Veneto in the 17th of December were reported almost 19 deaths per million people. We can rerun this the same graph as in the cumulative one. Here I'll copy paste because that's actually the same code, just by changing a few things, but the graph is the same. For example, here we could move this to the upper right. Let's run the legend to the upper right. Okay, that's a little clearer. As we have seen for the cumulative data, looking at the absolute values, we are underestimating the effects, the mortality for other regions other than the Lombardy. And looking at the second wave, another thing comes in mind. If for the first wave, okay, Lombardy was the region more affected by COVID. But in the second wave, actually, the Veneto, which is the orange line here, maybe reported deaths per million people higher than the Lombardy. So the strength of COVID in Veneto was actually comparable with the strength in Lombardy. Even if that comparison would make no sense in the first wave. Quite interesting. So let's compare Lombardy versus Veneto with the same graph here. Run. This can be a little bit confusing because the lines overlap sometimes. But again, the blue line here, blue solid line, is almost equal to the green and the orange solid line. So the strength of COVID during the second wave was almost the same between Lombardy and Veneto. Quite good. But here, looking at the daily data, can be sometimes the data can be noisy. You can see, for example, these peaks that makes not a lot of sense because we don't care if that person died in that specific day of the week. Maybe we can just look at weekly data. So let's take a look at incremental weekly COVID-19 deaths. What we can do then? We have to group the daily data by week. In order to do so, we apply to our table, our data frame, the group by function, specifying that we want to group by region and also by date by setting up a frequency of a weekly frequency. Of course, generally speaking, in a week we will have 7 date values for deaths per million. We then have to sum that 7 deaths since we are in an incremental setting. Then we reset the index and the date will be called week. And we came up with this table, region, week, in which week is still a date but refers to the Sunday of that week. And we have the deaths per million for that week. We run the same maybe let's ignore Emilia Romagna and Toscana. Let's focus just on Lombardy and Veneto. We rerun the same figure, and we can see that now the lines are smoother. The lines are bigger because I explicitly set the line width as 4. And here, from this noise, we question if the two waves, the second wave was equal between Veneto and Lombardy, and here we can see that they are quite different. Still, the wave in Lombardy was a little bit stronger, but in December the deaths keep increasing for Veneto, while for Lombardy they in the middle of December they began to decrease. In fact, you do not have to consider the last point here because the week is truncated. Since we are summing up between weeks, the last week, if the last week has not 7 days because of the date of observation, then this for that specific week the data will be underestimated. And finally, after this analysis between Lombardy and Veneto, we can start questioning about the historical monthly deaths. In particular, the main goal of this analysis was to compare the historical monthly deaths reported in the previous years and the non-COVID deaths reported in 2020. We import this CSV, the historical COVID monthly death comparison, as histcomp.md, monthly deaths. Let's take a look at how this is this table. Oh, excuse me, I forgot to run. Okay, we have quite a big table where we have the month, okay, of 2020, of course. We have the region, fine. We have a table, a column named COVID deaths 2020, average deaths, which is the average between these columns that we will see in a minute. We have the non-COVID deaths of 2020 that are computed by subtracting to the total deaths of 2020 minus the COVID deaths. And finally, we have the total deaths for 2015, 17, 17, 18, 19, and 2020. And the average deaths, as I was mentioning before, is the average between the total deaths reported for that specific month and that specific region between 2015 and 2020. For our convenience, it is better to this table is vertical in some sort, because we have several columns telling us about the total deaths, for example, right? We have one column for each year. For our convenience during plotting, we would like to have an horizontal table. For example, adding a new column named year, and for example, year equal to 2015, we report for that region and month this value, and so on. Also, we have different death types here. We have the total deaths, we have the non-COVID deaths, and we have the COVID deaths. Let's forget about the average. We can delete this table. And this is what exactly this cell does. It just manipulates using pandas the table. Let's run, and we will get this result. We will get a table with month, year, the region, the number of deaths, and the death type. The death type will be COVID, of course only for the year 2020, and this combination will refer basically to this column here. Instead, for total, we will have different values for year, and for each year we will refer to one of these columns instead. We then can compute the deaths per million people for each year now, for the COVID deaths, but also for the total deaths, and looking at the years between 2015 and 2020. Same code as before. Let's look here. We have by joining the new table with Italian and the Italian population table, we have the population where we can compute the deaths per million. Now since our main focus is to understand how to use Matplotlib and Seaborn, let's structure a new plot, and the result will be this one. So what we want to do, we want to plot 6 lines here with their legend, one for each here between 2015 and 2020, but also we want to draw a region by red with maybe some alpha that will represent the increase of reported deaths for that specific month that refer to COVID. Next, we have to add an arrow with this text. So, just one axis here. We use subplots defined in the figure. Okay, we add superior title, monthly deaths per million people for this specific region, which will be Lombardia. And then let's start looking at the total deaths. Okay, the 6 lines here. So what I have to do? First of all, I have to select only the total deaths. So let's create some masks. Mask 0 will be the, let's grab the new table, the new historical comparison monthly deaths, and we select that type should be equal to total. Okay, the total deaths. Second, we have that mask 1 should be new, this region equals to our region. Okay, that's fine. Let's draw the 6 lines. How can we do this? Well, 2 approaches. Use Pyplot or use Seaborn. Here the best way, of course, is to use Seaborn. If we can, it's always a good solution to use the Seaborn. So, Seaborn line plot, whoopsie, line plot, and let's define the option. X will be our date. Y will be what? That's per million. Fine. We will have the data that will be new history filtered by mask 0 and mask 1. Nice. But we want also to filter by the here, so let's add a U here. Okay. Now that we have selected the data, let's define some cool properties. For example, the palette. I've already chosen one specific palette, which is called Mako R reversed. Then we have line width of 4, and finally we tell that this line plot should be drawn using this axis. Let's run. Oh, excuse me, that's not the date, but we have the month here. Okay, that's cool. Now we have to draw the region, the red region, right? How can we do? Well, remember that we can use the fill between function, but we have to tell Pyplot the x-axis, okay, the months, but also the y1 and the y2. The y2 will be the top of this line. They're referring to the total deaths of 2020. And the bottom of the region we want to color will be the non-COVID deaths. So here, for delta deaths, we will create, let me just copy to make it faster. Create a mask which will be region, and here, of course, we have to select the 2020. We also select that type as non-COVID, as mask 1, that will be used for the Y1 option, and the mask 2 that will be used for the Y2 option. Now, axis, fill between. We tell X will be new, is the historical comparison monthly deaths, and we will query by mask, but and mask 1, and we select month. Y1 will be new, is will be mask 1, mask and mask 1 again, and we will select the deaths per million. Okay, we will do the same for Y2, but we will change one of the masks, and we will select the mask 2. Then we want that to be a color red, so color should be equal to red. And let's modify the opacity by selecting alpha equal to 0.5, for example. Okay, cool. But in this way, we don't know what that red area means. Let's add the arrow pointing to the that region and a text explaining what it is. We will use the annotate function. It takes as an argument the text. So the COVID-19 reported deaths. Okay. We tell where the arrow points through the parameter xy, and here I already let me just copy paste because I don't of course remember. Let's do something like this to make it a little beautiful. So xy is, you just have to take a look here. I want to point the arrow something here. So looking at the numbers is 3.2 as x and y 2100. The text, so the tail of the arrow should be something here, and this is the position, and I want the font size of the text to be 14. Then I want to also select some properties about the arrow, which are this one. Nothing special, arrow props equal, for example, the face color. I want the face color, the color of the arrow should be black. Then I select some shrink width, which is the width of the body, and the head width. Let's run. Okay, very cool. I've done the same for Veneto. And let's look at, for example, here. Let's go back to the Lombardy to analyze the results, the actual results. So here we have, apart from 2020, we have that the average, unfortunately, I have to mention this. Unfortunately, if you remember from the previous course, we do not have the data about the total deaths for the other months. For example, September, October, and December. So unfortunately, we can't look at the second wave, but we can look at the first wave here. And in the previous years, and from 2015 to 2019, we have that the average in the during February, March, April, and June was about 800 to 1000 deaths. In March, during COVID, instead, 2,500 deaths were reported, but only a few were attributed to the COVID. That's still a gap here, unexplained. And these are deaths that are reported to, that are referred not to COVID disease. And this is quite statistically significant. That's something strange here. This should be, in theory, COVID deaths, because the misalignment between the total deaths in 2020 and the total deaths in the previous years here is too high. The same for Veneto, but not that remarkable. We can say like this. Still in March, that's the main problem. So finally here the data is monthly, and using lines is not always optimal. We could use, for example, one tip that I can tell you is that when you have low frequency here, maybe using a line plot is not the best case scenario. Try to use also a bar plot. Maybe you can represent things better. Also here I don't want to represent all the lines between 2015 and 2019. I'm fine with an average and a standard deviation around that average. So the goal, for example, is to create something like this. We have a bar plot, a main bar plot that refers to 2020. We have that the blue bar here are the non-COVID deaths per million people in 2020. And the orange here are the COVID deaths per million people in 2020. While the black line here is actually the average monthly deaths per million people computed between 2015 and 2019. here things are even more clear that this gap is too significant to not be related to COVID. I've already done the same thing with Veneto, and you can see that the gap is still important in March, but not that much. Let's produce this graph, and then we can end this fifth course. Okay, first thing first, we create one single figure with one axis. How we can do? We select the region, subplots. I've already selected the dimension in inches, and the main title, monthly deaths per million people for this region. We start using creating the bar plot. So we have to refer only to 2020, and we have to divide and then the subplot into different bars, the blue bars and the orange bars. Okay. Let me fix this. So we have that types here will be two, the non-COVID, COVID, and the COVID. We create, excuse me, we also create a mask here where new is a historical comparison monthly deaths dot region should be equal to region, but also we are referring we are referring to the 2020. So new here equals to 2020. Then, for each of the death types, so for dt in death types, we have to create two masks. The first mask refers to the new historical comparison multiple deaths, death type, equal to that specific dt. And then we have the mask 2, which will be the same that type, but actually will be always equal to non-COVID. You will see in a minute why. Then we have x.bar, which is the vertical bar plot. In vertical bar, let's see, I have to explicitly tell the x and the y, and eventually the where to start from the bottom on the I. So to draw the blue, I have to start from 0 to the value of non-COVID deaths, or total, I would say. To total, excuse me, to non-COVID deaths. So we, as x, we will use new, quite slow, my computer, lock mask, because we have to select that specific region and then specific year, but also we want to select mask 1. and mask mount column. Then we have the height of our bar, which will be mask and mask 1 is this one, of course, and will be column there. That's fine. Just for our convenience, we will specify width equal to 0.6, a label which I will copy paste from my notebook, from my notes, which will be for example non-COVID or COVID deaths per million people. Okay, and then an alpha which will be equal to 0.8 if dt is equal to non-COVID, just an aesthetic option, 0.6. Okay, but now we have a problem, because for the first loop for non-COVID we have that we create a bar plot for each month that will have height equal to deaths. This means that it will go from here to here. But in the second loop we will have the COVID deaths. But we need to start from the top here of the blue bar and add the orange one. To do so, then, what we can do? Well, we need to add the option bottom, which will be equal to 0 if mask 1 is equal to mask 2 for all the elements. This means that dt is equal to non-COVID, actually. Else, you will start to draw the orange bar from the value of non-COVID. This means that we will use lock mask and mask 2.deaths. Let's run. Okay, that's not defined because I forgot from this one. Okay. Wow. Okay. The legend is already created and the labels are already set up. We finally have to create our average with the standard deviation. The first, so we will have to create a mask, but we select yes the region, but only the years previous to 2020. We want the average from the past. And also here we should compute the average, the standard deviation, or the some confidence interval, and so on. Could be tricky using Pyplot, but not with Seaborn. We use Seaborn, in fact, a line plot. We specify x as equal to month, y equal to depth, data equal to new, yes, lock, yes, lock the mask, color will be black. We want a black line. We type a label. Let me copy this label. Average monthly deaths per million people, period between 2015 and 2019. Maybe we can say computed. Okay, and then we can specify estimator. Estimator equal to mean. The confidence interval equal to 99%. So 99, and the axis would be axis. Let's run, and here we go. That's it. Why we can use estimator and it produces an average and mean? Because here, just by selecting region and the fact that the year should be less than 2020, it means that for each month there are actually 5 records. 5 records for deaths. Actually, here we should use, excuse me, here that's a mistake that we could correct immediately. That should be deaths per million. Okay. Something happened because this should be this one. Okay. Excuse me. A little mistake. Okay, because for each month here we have 5 records for deaths per million. So, how Seaborn should treat all these 5 records? Well, it applies the mean and also computes a confidence interval of 99%. 99%. This means that there's quite there are a lot of deaths that are unexplained by COVID, but there are off the mean and the confidence interval, but quite a lot for the Lombardy, for example. If you want to apply to produce the same graph for each region, you can just wrap it up all this code for using a function that takes region and the data frame as as arguments, and then returns, or maybe plots, if you prefer, the figure. So with this not scientific analysis, it's just data science and an exercise for our for Python and the Matplotlib and Seaborn libraries, we anyway find that probably some deaths attributed to non-COVID disease are seems actually COVID related. Another thing, I want to return a little bit and explain what we will treat in the next course. Another thing that we can do instead of wrapping this code inside a function could be to produce an interactive plot. Here the subtitle of this course is static plots with Matplotlib and Seaborn libraries. A way to present a lot of data in a simple manner would be to use interactive plots. For example, here we could have on the right a panel for selecting our region. We can select one of the region instead of plotting all the regions we want. Selecting a region, in fact, is faster, more scalable, because we don't have to store all the information for that plot, and also we don't have to type any code anymore once the dynamic plot, the interactive plot, is set up. That's what we will see in the next course. So take care and keep analyzing data with Python and the static libraries for plotting. See you in the next course. Bye bye.